The purpose of this video is to review how to solve unit conversion problems, something you should have seen in science or math classes previously. Just to review from the reading, a unit is a scale that we use to relate a measurement to some defined standard. The problem is in science, there are often different units to measure the same quantity, so we need to be able to convert from one unit to another. Here's an example. Suppose I want to know how many kilograms there are in 135 pounds. Well, the first thing I need to know is what is the relationship between a pound and a kilogram. So I look on my data sheet and I see that I have a statement of equality that says that 1 kilogram equals 2.2046 pounds. That will let me proceed. So I'll begin by writing down the measurement that I'm given in the initial unit, so 135 pounds. And if you want to put that over 1 to remind yourself that pound is in the numerator, that's fine. Then I'll multiply that by a fractional conversion factor that has the unit I'm trying to get rid of, namely pounds, in the denominator, and the unit I'm trying to convert into, kilograms, in the numerator. I will then add in the numbers that correspond with the units. 1 goes with kilograms, 2.2046 goes with pounds, and I'm set up to go. Pounds cancel pounds, and when I perform the mathematical operation, I see that I get 61.2 kilograms. Great. Now, here's another example. Suppose I want to know how many meters there are in 75 feet. Well, if I look on my data sheet, I will see that I don't have a statement of equality that tells me exactly how many feet there are in a meter. However, I do see that 1 meter equals 1.0936 yards, and 1 yard equals 3 feet. So that means I could convert from feet to yards and from yards to meters. But instead of doing this as two separate operations, I'll set it up as a single calculation. I'll begin by writing the measurement in the unit I'm given, 75 feet over 1. I will then multiply that by a fractional conversion factor that lets me convert from feet to yards. Feet goes in the denominator, yards goes in the numerator. 1 goes with yard, 3 goes with feet. And then I can simply add on another fractional conversion factor that will now cancel yards in the denominator and give me meters in the numerator. 1 goes with meter, 1.0936 goes with yards. Unit cancellation works. Feet cancels feet, yard cancels yards, and I'm left with meters. And when I perform the math, I see that I get a value of 22.9 meters, which I'll draw a box around. Now remember, when you're performing an operation like this on your calculator, you want to take 75 feet and divide that by the product of 3 feet and 1.0936 yards. So on your calculator, you would simply enter 75 divided by the product of 3 and 1.0936. And if you do that correctly, that will give you the answer, 22.9 meters. As a final example, what to do about measurements that actually have fractional units, 1 unit in the numerator and 1 in the denominator. Here's an example. The density of water is 8.35 pounds per gallon. I want to convert that into units of kilograms per liter. Well, if I look on my data sheet, I'll see the following statements of equality. 1 kilogram equals 2.2046 pounds. That will let me convert the numerator from pounds to kilograms. And I also have 1 gallon equals 3.7854 liters, which will let me convert my denominator from gallons to liters. And I'll set it up in exactly the same way. Begin by writing down the initial measurement in the unit you're given, but now I'm going to write it as a fraction. 8.35 pounds over 1 gallon. And it doesn't matter the order in which you convert. You can either do the numerator first or the denominator. I'll do the numerator first. I'll multiply this by a fractional conversion factor that has pounds in the denominator, kilograms in the numerator. 1 goes with kilograms, 2.2046 goes with pounds. That will cancel pounds and give me kilograms in the numerator. But now I'll use a second conversion factor to cancel the unit in the denominator and change it from gallons to liters. And for that, I'll want gallons in the numerator and liters in the denominator. 1 goes with gallons, 3.7854 goes with liters, and now gallons cancel gallons, and I'm left with units of kilograms in the numerator, liters in the denominator. I perform the mathematical operation, and I see I get an answer of 1.00 kilogram per liter. And that's pretty much it. I hope you find this helpful.